Welcome to this course on Process Design. In this lecture series, we will explore the fundamental principles and practical tools that chemical engineers use to design industrial processes. Process design is the foundation of chemical engineering practice, as it transforms scientific knowledge into safe, efficient, and profitable industrial systems. This first module focuses on the factors influencing process design, the use of process diagrams, and the essential concepts of material and energy balances. Section 1: Factors relating to process design. Before drawing diagrams or performing calculations, it is important to understand the factors that shape process design decisions. These include: technical feasibility, is the process technically possible with current science and technology? Economic viability, will the process generate profits, considering investment and operating cost? Safety and environmental concerns, can the process be operated without undue risk to people, property, or the environment? Availability of raw materials, is there a reliable supply of feedstocks at a reasonable cost? Product demand, is there a strong and sustainable market for the product? Energy requirements, does the process demand too much energy, or can it be optimized? Regulations and standards, are there industry codes or government regulations to follow? Every design project balances these factors. An excellent technical design may fail if it is uneconomical, while a highly profitable design may be unacceptable if it harms the environment. Section 2: Process diagrams. Process diagrams are essential tools for chemical engineers. They provide visual representations of how materials and energy flow through a process. Let's briefly review the main types. Block diagrams, these are the simplest diagrams. They represent major process steps as blocks connected by arrows showing the flow of materials or energy. They are useful for early communication with non-engineers. Process flow diagrams, PFDs, these diagrams are more detailed. They show major equipment such as reactors, distillation columns, and heat exchangers, along with the streams of materials between them. PFDs help engineers understand the overall sequence of operations. Process engineering diagrams, these include more technical details such as stream compositions, temperatures, pressures, and flow rates. Piping and instrumentation diagrams, P&IDs, these are the most detailed. They show all pipes, valves, pumps, control loops, sensors, and instrumentation. P&IDs are used by plant operators, safety engineers, and construction teams to actually build and run the facility. In practice, process design typically begins with block diagrams and gradually evolves toward P&IDs as the design matures. Section 3: Material balances. A central task in process design is performing material balances, which ensure that mass is conserved throughout the process. Material balances are used to calculate feed and product quantities, evaluate the efficiency of recycle streams, determine the buildup of inert materials, size equipment such as separators and reactors. When a process includes recycles, the balances become more complex. Recycle streams may reintroduce unreacted materials or solvents back into the process, while inerts must be managed so they do not accumulate. The logic is straightforward: what goes into a process must either come out as product, byproduct, or waste. Section 4: Energy and heat balances. In addition to material balances, engineers must ensure energy conservation through heat balances. Heat balances help us size heaters, coolers, and heat exchangers, estimate fuel or steam requirements, identify opportunities for energy recovery. For example, heat released from an exothermic reaction may be recovered to preheat feed streams. Such integration reduces operating costs and improves sustainability. Section 5: Software applications in material and energy balances. Modern chemical engineering relies heavily on software to perform complex calculations quickly and accurately. 3 categories of software are commonly used. Microsoft Excel, a flexible spreadsheet tool often used for preliminary material and energy balance calculations. Excel allows engineers to build customized models, test scenarios, and generate charts. Commercial simulation software such as ChemCAD or Design 2000, these programs can model entire chemical plants, taking into account thermodynamics, unit operations, and recycles. They significantly reduce calculation time and improve accuracy. AutoCAD, used to generate process flow diagrams and sometimes PNIDs. AutoCAD provides precise engineering drawings that can be shared across teams for construction and plant operation. By combining fundamental engineering knowledge with software tools, engineers achieve efficiency and precision in process design. In this first module, we covered the key factors influencing process design, the hierarchy of process diagrams, from block diagrams to detailed PNIDs, the principles of material and energy balances, the use of Excel, ChemCAD, and AutoCAD in calculations and diagram generation. With these foundations in place, we are ready to move into Module 2, which will focus on equipment specification, utilities, and economic analysis.